String superstars of Swift. In this lesson, we'll tackle the reveal word after last guess challenge that we posed at the end of the last lesson. We'll use techniques that we've emphasized so far in the course, but then we'll also introduce the map function, so we can see how to achieve an even more efficient solution using a Swifty functional programming technique. Let us pluck those strings for a sonata of Swiftiness. So at the end of the last lesson, we learned a smorgasbord of string-centered techniques, and we posed this challenge to produce code that we'll use in the Hangman-style WordGarden app that we're creating in this chapter. The idea is to compare the word the user has to guess with the letters they've guessed so far, then create a string that reveals the letters that have been properly guessed and has underscores for the letters that haven't been guessed. There should be spaces between the letters and underscores. Let's look at a solution. And the playground that I'm showing here is the string work playground that we were using in the last lesson. So we'll start with a comment here, reveal the word, and also print a line that says reveal the word. Now the comment should say reveal the word, not reveal the world. That would be an entirely different app. And on the next line, we'll say word to guess equals Swift. And then under that, we'll say var letters guessed equals, and we'll start out with the same thing we had in the challenge slide, SQFTX. So we haven't added this part to WordGarden yet, but eventually each letter that the user guesses will be added to this string letters guessed. And on the next line, we'll start with revealed word equals empty string, and we'll fill this out in our code. Then we'll put in a comment, loop through all the letters in word to guess, and we'll loop through with 4 letter in word to guess, open and close curlies. So here we're checking to see each letter in word to guess to see if the letter in word to guess is in letters guessed. In other words, we're saying, did you guess this letter already? So the way we do this in code is we say if letters guessed dot contains, remember that guy from last lesson, letter. Then open and close curlies, and we write this in our code as revealed word equals revealed word plus string interp, letter inside the string interp, and a space after the string interp. Then after the if case curly, we'll say else, open and close curly, and I'll add a comment. If not, add an underscore plus a blank space to revealed word. And in the code, that's just revealed word equals revealed word plus the string underscore space. Then after we've gone through all of the letters using the for loop, remember we're going to have an extra space at the end, but we remove that extra space with revealed word dot removed last. Open and close parens at the end, but code completion inserts those. Now let's print out these values. We'll say print word to guess equals string interp word to guess, print letters guess equals string interp letters guessed, and print revealed word equals revealed word. Now let's shift enter and marvel at the majesty of your code. Word to guess is Swift, letters to guess is SQFTX as expected, but here's the big result. The revealed word is S__FT. This is looking good. Let's change this up a little bit to make sure that things are working right. What if we add a W to the letters guessed? Shift return at the end, and nice, we get SW_FT. What if we guess a bunch of letters that aren't in the word? So we'll change letters guessed to QXRLM, shift return, and at the end we see the revealed word is all underscores. Nice. Then I'll Command Z to undo and get back to the previous letters guessed. And now let's change the word to guess from Swift to, how about Star Wars, all caps as one word, may the force be with you. And then we'll shift return at the end, and oh, will you look at that? It recognizes STW, and S appears twice in this word, even though we guessed it only once, which is exactly the result that we want. And I'll show you one more method which uses the map method. Now map uses a technique called functional programming, and in functional programming we transform data through functions rather than through loops. This allows our code to be much more compact, and if you're new to this it might look a little bit strange at first, but functional programming using .map is very common in Swift, so you should know how to use it, and many other modern programming languages have a feature like this as well. So when we put .map after a sequence like a string or an array, it works on both. We go through each element of the sequence. So in this case, we're going through each letter in the string word to guess. And we're going to transform that using the instructions that are in the closure, inside the curlies here. And this is going to return an array of transformed elements. So that's very important to know. .map gives us an array, which isn't really what we want. We want a string, but we're going to be able to work with this. Watch. So when we say word to guess .map, we're going to go through every letter of word to guess. We're going to refer to each individual letter as letter, so we give it a name, just like that name we give a constant in a for statement. We could name it anything, but in here we refer to each individual letter as letter. We put the keyword in after this, and then what you have in between the curlies of the map statement is similar to what you'd have between the curlies of a for loop. Now we could put any code in here, but we're using a ternary operator. We're checking to see if this letter from word to guessed is in letters guessed. If this is true, the contains function returns true, then we add this letter to an array named revealed word array. But if the letter is not in word to guess, then we're going to add an underscore to the array called revealed word array. So we go through all the letters in the string variable word to guess one by one. We see if each of those letters are in letters guessed. If it is, we add a letter to the array. If not, we add an underscore to the array. Now .map produces an array, and that's not what we want. We want a single string that contains each element of the array, the letter or the underscore with spaces in between the letters or underscores. But we learned a function earlier that we can use for that. .joined. That joins elements of an array into a single string, and .joined has an option where we can pass in a separator, which is a string to put in between the elements of the array when it creates a string. So since .joined gives us a string, we can assign the result of this to our revealed word string. We don't need to use revealed word array anymore. So by using these various techniques together, we took what was on 7 lines of code and put them in just 3 lines of code. Let's enter this first, and then I can show you how we can shorten this even more. So first, let's print out a string \n map. Then we'll say revealed word equals word to guess dot map. Now Xcode knows I'm calling this on a string, so what it's going to do is iterate through every character in the string. You see character in here, and it says it returns an array containing the result of mapping the given closure, that's the stuff between the curlies, over the sequence's elements. That's each letter of the string. This is what we want, so press return. And we'll press return again for trailing closure format. And this first value is asking us what should we call the individual letters that we iterate over. It says it's going to be of type character. I think letter's a good name. Then I'll tab over to the body of the curlies, and this is where we're going to put our ternary operator. So we're going to say letters guessed dot contains. Remember, dot contains returns a bool. This is going to be either true or false, so press return. We're going to pass in letter. Then to use the ternary operator, we add a question mark, and then after this, what do we do if it's true? Well, we want to pass back the letter. Now letter says string element in here, but we learned in an earlier lesson that that's the same thing as the character type. And we've got a couple of ways to convert this. I'm going to convert it using string interpolation with double quotes, backslash, parentheses, and in between the parentheses, I'll pass in letter. That'll convert it to a string. But if the string is not contained inside of letters guessed, then colon, if it's false, we'll pass back the string underscore character. By the way, a bit of shorthand you'll see in here, you don't need the parentheses around map. We can actually delete those so that we just have curlies. Most developers prefer that. It looks neater. Now we're getting an error up here. Cannot assign value of type array of strings. See the string surrounded by square brackets? That's an array. To type string. We're trying to combine 2 different things. Can't do that in a type-safe language like Swift, but we know how to fix that with our buddy the joined method. So after the closing curly, we'll say .joined. We'll choose the option with the separator in here, and code completion says that this returns a new string by concatenating the elements of the sequence, which can be an array, and that's what we're getting back from the map function, adding the given separator between each element. Press return to accept this. What should the separator be? A single space between quotes. So let's copy these 3 print statements and paste them down below so we can see our results. Shift-Enter, and we see the expected result from Star Wars. Nice! Some letters revealed, including a double reveal of S. Some letters that we haven't guessed, those are the underscores. Let's see, let's find these values for word to guess, letters guessed, and revealed word. I'm going to copy them and I'm going to paste them above the code I just wrote. I'll remove var in front of letter guessed because that's already declared. Let's change word to guess to Swift, shift return, and the revealed word is almost done, looking good. What if none of the letters guessed are in the word to guessed? How about Q, Z, L, X, and Y, shift return, and we get 5 underscores. Spectacular. So if we take a look at our code, we just wrote 3 lines of code here, and these lines do the same as, let's count them up, 1, 2, 3, 4, 5, 6, 7, 8 lines of code if you don't count the comments. But swifter, we can actually get this down to 1 line of code. Let me show you. There's something called functional programming shorthand. I'll copy the 3 lines of functional programming code using map that we just wrote, and underneath where I say functional programming shorthand, I'll paste those 3 lines in, and after the map, we have letter, which for us is what we call the value that holds the individual letter as we go through all the letters in word to guess, and that's followed by the keyword in. But we can get rid of letter and in. Swift knows we're going to iterate through our sequence. In this case, it's going to iterate through a string. So instead of giving this a formal name, we can actually replace letter with $0. So we'll do that in both places on this line here. Letters.guessed contains $0, and if it's true, we'll pass back the string $0. And since we're using $0, that's this automatic name, well, we don't need letter in. We're using that automatic name, $0. That lets us put everything in between the curlies on one line with a curly on either end. And you can see all this code is on line 149. Swifter, we wrote this code on a single line of Swift code. Let's shift return at the end to execute this code, and Grace Hopper's moth. Will you look at that? We get the same results with just one line of code. So Swifter, we learned about functional programming with map. We learned about the $0 naming shorthand. It's up to you whether you want to use the 3 lines of code or the 1 line of code. You will see developers use that naming shorthand with the $0, although it is admittedly tougher to read, but it's a convention you'll get used to and that you should know. Swifter, you are now a string sorcerer. Be sure that you Swift on back in the next lesson because we're going to apply this code in our WordGarden app. Swift on!